In today's video, we're going to look at section 6-5, analyzing graphs of polynomial functions. So before we get started learning to analyze, we need to let's run through an example. So I've got something set up. Graph f of x is equal to x to the fourth plus x to the third minus 4x squared minus 4x by making a table of values. All right, so there's a lot of numbers here, and you're going to see why, because as we go through this, something's going to trend and you're going to figure out why I did this. So I'm going to start by just working with the whole numbers. So -2, -1, 0, and 1. So now all these numbers I have ready, but all of them can be found very quickly by using a calculator. So first, when we take -2 and plug into our calculator, we actually end up getting 0. We get 0, okay? And then I'm going to move on to -1. We get 0 again. Then we plug in 0 and we get 0. If we plug in 1, we get -6. And then if we plug in 2, we get 0. So as I graph this, now my graph is going to go by 0.5s, so please keep that in mind. So if I go to -2, so -2, 0, there's the first point. I'm going to do different colors, easier to see. Okay, going by halves, just so we know. Okay, and then I go to -1 and I get 0. And then I go to 0 and I get 0. And then I go to 1 and I get -6. Now that's way down there. Let's see, so -6 would actually be right about there if I'm going by 0.5s. And then I go to 2 and I get 0. Okay, that doesn't help me at all. I have no idea. So we need more numbers. We need more. So I'm going to plug in these 0.5s. So if I plug in -2.5, I get 8.4. -1.5, I get approximately 1.3. Oh, negative, sorry. At -0.5, I get approximately 0.9. At 0.5, I get -2.8. At 1.5, I get -6.6. So now I have a little bit more information if I were to graph this. So if I go to -2.5, I go to 8.4, and that is way up here. That's going to be somewhere way up here. -1.3 for -1.3 is approximately right there. Oh. All right. -0.5 is approximately 0.9, so right about there. And then 0.5, -2.8, about right there. And then 1.5 is -6.6. So that's right about, not much farther. So now I got a little bit better. Now I can, but if we take in what we learned yesterday in the last lesson, we can tell the end behavior. We have a coefficient of positive and a degree of even, so both are going to end up going positive. So if I follow that trend, I can kind of follow my points and go, wait a minute, it should kind of trail something like this. And it'll keep going, it'll drop back, keep dropping way down. And I know it needs to end up on the positive, so I'm going to keep going back up. So it looks something like this. Now, it's not going to be perfect, but you have an idea of what it looks like. That's why we always say the more numbers, the better. So what we're truly looking at is a graph that crosses the x-axis. So suppose y equals f of x represents a polynomial function, and a and b are two numbers such that f of a is less than 0. So when you plug in a number, you get a negative number, and then you plug in another number and then get a positive number. What this is telling you, that at some point Okay, so here's A, here's B. At some point on the graph, you have to cross the x-axis, meaning there's a 0 there. There is a number for on the x-axis that the answer will be 0. That's what it's trying to say to us. Okay, so that's what we're looking for. So determine consecutive integers values of x between which real zeros exist. And then draw. So looking at the polynomial, we have a degree of odd and it's positive. So we know the end behavior should be down here and up over here. Just kind of an idea. So now, again, all these numbers can be grabbed very easily on a calculator. I have them already. So I have -2, and I get -32. -1 is -7. When we plug in 0, we get 2. When we plug in 1, we get 1. When we plug in 2, we get -4. Plug in 3, -7. Plug in 4, -2. And then when we plug in 5, 17. Okay, so just looking here, we can see we're looking for sign changes. Well, from -1 to 0, our answer goes from negative to positive, so must be a 0. So here there must be a 0 between -1 and 1, -1 and 0. Okay, and then again we have from 1 to -4. That means it's crossing. It's going to be passing 0 again, so also must be a 0. And then finally, again, -2 to 17 must be a 0 because again, it's crossing the x-axis. So that's what we're looking for. Not a very good. So now I'm just going to graph these real quick. I can't graph all of them. I'm going to graph the main ones. So if I go -1, -7, uh, 0, 2, then 1, 1, 2, -4, 3, -7, 4, -2, and 5, 17. And so 5, 17 is way up here. Like I'm not even going to try to graph it. Just going to put a dot there. Okay, and then I know again 2, -32 is way down there. So as I'm trailing up, it kind of follows the same thing. So it's not going to be a very good graph. So I'm crossing, and then again I'm crossing. I'm going through and I'm crossing again, and then I'm crossing again. Okay, so again, if you look at the graph, look where I crossed between all those numbers. Okay, I crossed the x-axis between -1 and 0. I crossed between 1 and 2. I crossed between 4 and 5. So that's what we're looking to do. Okay, so again, determine the x-coordinates. And now relative max and relative min are about the max. Now we can't tell exactly based on a rough draft, but you can kind of estimate. So let's plug this in here. So here we go. It doesn't say anything about finding zeros, so we're just looking for relative max and min. So again, all these coordinates can be plugged in. So -2, we get -15. -1, we get 1. 0, we get 5. 1, we get 3. 2, we get 1. And then 3, we get 5. Okay? So, once we graph, let's just graph this really quick. -2, 15, that's way down here. Then we get -1, 1. 0, 5. 1, 3. 2, 1. And then 3, 5. So, if we're following it, and it's x cubed, so it's going to be offsetting. I'll try this as best as I can. So, I'm coming up. Now, I don't know exactly what, because I'm not graphing every point around them, but we can see there is a relative, it's relatively at the top there and relatively at the bottom there. Okay, so these are relative because we're talking about the points around it. So this is a relative max because it's at the highest point around it. So that would be this point right here. And then a relative min. Now let's do green. Because that is its relatively low point. So at 2, 1. Right? So that's what we're talking about when we talk about relative maximum.